Hey friend, it's Colin from SonicScholar.com. Welcome back to our C# data structures series. In the previous video, we took a closer look at linked lists and we implemented the generic SimpleArrayList T interface for those. Today, we'll be taking a slight detour and discussing enumerators. While enumerators aren't data structures in themselves, they are a powerful feature that makes working with all kinds of data structures useful for algorithms that need to search and act upon that data. So just a heads up, to follow along with today's subject, you'll need a cursory understanding of object-oriented programming. So I've made a free C# object-oriented reference guide that covers essential OOP topics. For today's video, I recommend refreshing yourself on classes and objects, interfaces, and generics. Check out those sections from the guide as those topics are particularly relevant for enumerators. So don't miss out on that valuable resource. Brush up on those topics so you can grasp the content of today's topic more effectively. Link is in the description, or go to www.sonicscholar.com/OOP. Now back to enumerators. You may have seen them in action without even knowing it when using a for each loop in C#. Under the hood, for each uses enumerators to iterate through a collection. But what exactly are enumerators and how can we implement them in our data structures? Let's take a look. Pay attention to two specific interfaces that sound a lot alike, but they do different things. The interfaces we'll discuss are IEnumerable T and IEnumerator T. Typically, you make a data structure enumerable by letting it implement the IEnumerable interface. Now, IEnumerable is a simple interface that just has one method, getEnumerator. GetEnumerator returns an object of type IEnumerator of type T. The IEnumerator T interface is what provides the bread and butter for making enumerators work. This interface simply defines three methods and one property. For the methods, we have moveNext, reset, and dispose. And there's just one getOnly property called current. You almost never write code that uses those methods directly. Instead, what the compiler does is it automatically generates code that utilizes those methods whenever you use a for each loop. Now, there are a couple rules when it comes to implementing the IEnumerator interface. First, always implement moveNext and current. Okay, those are the core functionality of the enumerator, allowing it to traverse the data structure and access the elements. The reset method is technically optional. According to the docs, it's mainly for COM interoperability. Don't worry too much about that. In most cases, it's okay to just throw a not supported exception. Dispose method is also optional. It's used when handling unmanaged resources. So for example, let's say you needed to open up some kind of network connection to fetch data. Once you're done enumerating, the dispose method can help close that connection down reliably. Again, it's optional, and for our case, we're not going to use it. In most cases, it's fine to just leave that implementation empty. Now, let's come up with a game plan for updating our SimpleArrayList T from the last video to IEnumerable T. First, we'll need to modify our SimpleArrayList T class to implement the IEnumerable T interface. This interface requires us to implement a single method, getEnumerator, that returns our IEnumerator T object. Again, that object is responsible for iterating through the items in that collection and keeping track of the current position as we're enumerating through. Two, what we're going to do to support that, we'll create a SimpleArrayList enumerator class that implements the IEnumerator T interface that we discussed. Okay, enough planning and talking. Let's dig into some code and check it out. Okay, here we are in the code, and the plan again is we're going to do 3 steps. Make the SimpleArrayList implement the IEnumerable T. We're going to create an enumerator class for the array list, and then stick around because there's a whole lot easier way to do this, but it's one of those things that you'll understand once you know kind of the hard way to do this. So that's using the yield keyword. So Let's go right into our unit test and demo how we want this to work. We want our array list to be enumerable in a for each loop. So let's make a test that does that. We'll add some items in there. We want to grab the items and then check the expected value. So the first item should be 1, the second item should be 2, the second item should be 3. And after each run through, we'll increment it. So by the end of this loop, this expected value should be 4, right? It's going to start out as 1. We're going to check 1 is equal to 1. That'll go to 2. 2 is 2. That'll go to 3. 3 to 3. This will go to 4 at the end of this loop, and then there's no more items in the list. So once the expected value is 4, we'll kick out of this for each loop. And then just to make sure that we've actually hit everything in the list, we'll assert that the expected value is 4. And first things first, if I try to build, it's not even going to work because it's saying that the SimpleArrayList class does not have a enumerator. So what we need to do is step 1 here, make this class implement the IEnumerable of T interface. Hit Control Dot to implement the members. There's 2 getEnumerator methods. That's just because the IEnumerable of T interface actually implements the IEnumerable interface. One's generic, one's not. So here's our generic interface. That one implements the non-generic interface, and if I go look at that, it has a getEnumerator as well. That's why when you look at the generic version, notice it has the new keyword. It's just saying, hey, I have a method called getEnumerator, and it's the same value as the enumerable one. So we're just going to say, yep, I'm intending that this method could cover up the one that I'm implementing. It's not something you really even have to worry about because it sort of took care of that for you. IEnumerable.getEnumerator. This is what's called an explicit implementation of the IEnumerator interface. And all it's doing is just returning this guy. So this guy just calls this guy. Again, not something you really need to worry about, but just to understand why that's there. At this point, I can run a build and the compiler error should go away. Remember before in this list here, it was saying, hey, this is not enumerable. There's no getEnumerator. Well, that's been taken care of. So now we can go to step 2, which is to create an enumerator class. Recall that the enumerator class implements the IEnumerator of T. GitHub Copilot is awesomely proposing an implementation for this. So let's take that, but then scrutinize everything because this is how you can really get into trouble sometimes. So we've got our class, SimpleArrayList Enumerator, implements the IEnumerator of T. It's got 2 fields. So it's going to have a reference to our SimpleArrayList of T. That's really important. And it has a current index that defaults to -1. If we look at how this is initialized, we just have our constructor here. We pass in the list as a parameter and save that out as a member variable. We have the move next. That's not optional. We have to implement that. The current index is always incremented. And then we have to return true or false depending on whether there's a next element. And so what it does is it checks, is the current index less than the size of the array list? If so, that's true. We can return true, saying, yep, there's another element that we can return, but I don't know if this is totally correct. We have our unit test to test this out and see if it's right or not. I think this will be correct because the current index is always getting incremented. So I could imagine what's happening here. We start at -1. You always call move next before you get an item out of the array. So if we look here, right, for each, we have our list item. It doesn't just grab the item at -1 first. The way that for each works is it will call move next and then call the current property to get the item at that location. So on the surface level, this looks correct to me. Now the reset method is optional, but it's implemented here simply as returning the current index back to what it was by default. We have two properties here that are both called current. This is kind of the same problem we just talked about with the get enumerator. See, we have a enumerator of T, that's a generic version. If we go look at enumerator of T, it implements the enumerator non-generic interface. And we look at that, and this is the one that has move next and current that is just a plain old object. Again, something that you don't really need to worry about, because in the automatic implementation, it should take the explicit implementation of the enumerator's current and just return the generic version. So again, this guy just calls the other guy. Speaking of which, what's going on here is we have our list, and it's just returning the element at that current index. Remember, this accessor here is what we've implemented here. It just delegates the accessing of that index to the array that's backing the data structure. Not too complicated. Finally, dispose is optional. There's nothing to clean up here. If, for example, we're going to open a database connection, we need to clean up certain network-related resources or other unmanaged resources, this is where we do that. But for now, we just leave it empty. Getting a little compiler warning or IntelliSense warning saying there's a possible null reference return. That's because object can be null. Not something I really care about. So I'm just going to hit Control dot on here and say suppress the nullable warning. All it does here is it puts an exclamation mark on the end. That's some newer C#. It wasn't around when I was learning C#, but there you go. That's all that's doing. We'll run a build and let's see where we're at with our unit test. Of course, we've implemented the enumerator class, but we haven't wired everything together. We're still throwing this new not implemented exception. So let's fix that. What we're going to do is new up one of these enumerators. Remember, all we do is we take a reference to an array list and we pass it in, and we are this array list. Just forgot my new keyword there. Now I think everything should be piped up together. Let's run this again, and it's passing. Great. Let's take it a step further and run the code coverage, and let's take a look. Notice that not all of the code is covered. What isn't being run? Well, this reset. So there's your proof that the for each loop does not call the reset button because our code coverage is saying it's not there. It's also not calling this particular implementation the non-generic enumerator of the current object. Notice this guy is fully covered, the generic version. So again, nothing we can really do there. That's just how for each is going to use it. I could, of course, go write some more in-depth tests to test these kinds of things, but I'm going to leave it for now. And in fact, I'm just going to exclude this from my covered results for the rest of this demo because I'm expecting them not to be called. And otherwise, we're 100% covered than those things that we chose to ignore. Now, here's the fun part. Notice how much this boilerplate is. I mean, there's a ton of lines of code here. You have to be kind of careful. I mean, thankfully, I had GitHub Copilot suggest to me a perfect implementation, but it's really easy to get some of these characters wrong, like, less than, or as opposed to less than or equal to, knowing whether you should start at -1 or what cases you're supposed to return. So there's a much shorter way that we can do this. And to prove this out, I'm just going to get rid of all this, comment it all out, get rid of this return statement here. And you can see what's going on. GitHub Copilot is going to generate for me an example where it's just a simple for loop. Start at 0 while I is less than size, increase it, and then this is where the magic comes in. Yield return the value at that index, and this just magically returns for us an enumerator of T. This is awesome. Look at how much fewer lines of code this is compared to what we had to do here. This is what we call syntactic sugar, right? The syntax of C# is doing something for us that otherwise would have taken a lot more lines of code. I think the best way to look at this is actually to reverse engineer this code, and I'll show you. We'll kind of treat our code like a black box, look at the output DLL, decompile it, and see what the heck is going on here with this yield return keyword. Quickly make sure that my tests are still passing, and then we'll move on. Perfect. All right, I've just loaded up a program that I have called .peek. It's by JetBrains. Same people that made the .cover results that I was using there earlier. So what I can do is take the output of our application, and I'm just going to drag it right in here, and we'll use this to reverse engineer what's going on. Inside the Sonic Scholar data structures namespace, I've got my simple array list. That's where we were just messing around. And if I look at the get enumerator, what you might see by default, if we have high level C# is this here, right? We've got the get enumerator, we've got our yield return, all that good stuff. But what we can do is if we change this to low level C#, you can see what's going on. There's a lot more funkiness going on here, some extra attributes that are shown. So let's go back and look at that get enumerator method. This is now changed quite a bit. All right, this is quite a bit scarier if you're looking at this. We have some iterator state machine attribute. I don't know what's going on there. We've got all these like underscores and numbers and thing called enumerator. So what the heck is this? Well, really, just to put it plainly, the compiler generated an enumerator class for us, right? It did step 2 for us. If we scroll down just a little bit, you can see this compiler generated attribute. And look, here's a private sealed class. Sealed just means can't be inherited from. It's called D14. There you go. Literally, that's what that was. It's just making a new object of this, little keyword that it came up with. Check out this class. It implements the generic IEnumerator, the non-generic IEnumerator, and IDisposable. It's got 2 variables in here. It's got an integer for the state. It's got whatever the T is, our generic for the current. It's also got an array list. It's keeping track of that as a member variable. And it's got something else. I have no idea what it even is. Here's a constructor. Don't need to worry about that too much. Look, we've got a dispose method that's empty, just kind of like we did. We have a move next implementation, a little bit more complicated. All these funky little angle brackets and numbers. If you're astute, you would quickly realize that some of these identifiers start with numbers, and that's not allowed in normal C#, but because it's compiler generated syntax, it's able to skirt the typical rules of C#. But look what's going on here, right? There's some incrementing, there's some saving out of the state. It implements the current method. Check this out. Here's a reset method, and it just throws a not supported exception because it never gets hit in typical C# code. Another current property here. So a lot of stuff that would be painful to look at, but in essence, it's exactly what we did. It just has auto-generated names for everything and some attributes that hide stuff so that we don't have to look at this in the C# in our debugger. So there you have that, a quick cursory view of IEnumerable, IEnumerator, and enumerators in general. Hope you enjoyed that. Hit the like button if this was helpful. And if you've been following along with the playlist so far, I've got some homework for you. Take our linked list example, you can see that in the previous video, and see if you can apply the same thing we did today for the linked list data structure as well. And I think some of these concepts will sink in for you. Again, check out that object-oriented field guide that I've put together for you free of charge. Link is in the description. You can check out the course I have as well. Enjoy this homework assignment. Hit the like and subscribe if you find content like this helpful. And I look forward to seeing you in the next video.